video, we focus on cracking hydrocarbons. Last lesson, we have learned fractional distillation of crude oil. We know that crude oil is a mixture of hydrocarbons, and hydrocarbons are compound that contains only hydrogen and carbon atoms only. Now, that fractional column can separate hydrocarbons into different fractions. At the top of the column, the molecules are small, so they're highly flammable. They're good fuels. At the bottom of the column, the molecules are large in size, and therefore they're not good fuels. They're not flammable. Crude oil is a non-renewable energy resource. It's going to be run out one day, so we crack these large molecules at the bottom into smaller ones, making it more useful fuels. This is called cracking. Now, what is cracking? What are needed? What are the products? And why is it necessary? Is what we are going to learn for this lesson. This is a setup of cracking paraffin oil in a laboratory. Here is a boiling tube. Inside this boiling tube, you have mineral wool soaked in paraffin oil. And here you have porcelain pieces in the middle, so your Bunsen burner is heating the porcelain chips directly. As this is heated, the paraffin oil is vaporized, going through these porcelain pieces and through this delivery tube. All the way will be collected in this test tube, which filled with water. Now, the gas displaces the water, you will be collecting a test tube of gases. You can repeat it a few times and collect 2 or 3, maybe 4 test tubes of these gases. Now, when you compare the products of the gas to the original paraffin oil, you will see a result table like this. Now, paraffin oil was a clear liquid, but when it's cracked, the gas collected also very clear, so both clear in appearance. And when you smell the both substances, paraffin oil did not strong smell. You don't smell much. And the gas you produce have a very strong smell. And when you try to burn paraffin oil, it's not easy to burn. It's not flammable. And the gas is very, very flammable. And if you both react with the bromine water, now paraffin oil do not change the color of bromine water, whereas gas turned the bromine water colorless. So from here, you can see that the gas you produced is a unsaturated hydrocarbon because it's able to turn bromine water colorless, and the paraffin oil isn't. So looking at this table, you can see that the products is more useful. Why? Because the products, they're highly flammable, so they're good fuels. And paraffin oil, the previous reactants, they're not flammable, so not good fuels. So by cracking, we really have produced good fuels. And these good fuels also are unsaturated, so it's very reactive, more reactive than the previous one because it turns bromine water colorless. So you can see from here, the reaction is really like this. So you have got a long chain of hydrocarbons, let's say it's a paraffin oil. When you heat it up with porcelain pieces, you literally have break it down into smaller pieces. So they still have the different numbers of carbon atoms. If you count the numbers, they're all the same, and hydrogen numbers the same, but they are smaller. They have 4 smaller products, and These three, they're carbon double bond, means they are unsaturated. That's why they can turn the bromine water colorless. So cracking is a chemical reaction that's able to break down the large molecules into smaller molecules by heat. And the temperature, high temperature, and a catalyst is needed. In this case, catalyst is this porcelain pieces. Or we can also use aluminium oxide. So catalysts can be porcelain pieces, can be aluminium oxide or silicon oxide. And you also need a very high temperature, so 600 degrees Celsius, to crack the hydrocarbons. So if we go back to the questions, what is it? What is a cracking? What is cracking? What are needed? What are products? And why is it necessary? Now, you should be able to get this conclusion. The cracking is a process when large hydrocarbons are broken down into smaller molecules, more useful ones. And this is called cracking. So cracking also can be referred to as thermal decomposition reaction because it's a process of broken down large molecules into smaller ones by heat. So that's question one. Question two, what are needed? Of course, is a high temperature and a catalyst. Now this catalyst, you can give a name, either aluminium oxide, or you say porcelain pieces, or you just say it's a catalyst. That'd be okay. And they say, what are the products? You need to remember one of the products must be ethene. So you have many smaller products, depend on what material to start with. You have different products. They're all smaller than the previous one, but one of these must be belongs to ethene family, which means it must be a carbon-carbon double bond. So here, so what are the products? You say ethene is one of the products, which is unsaturated hydrocarbons, and other shorter alkanes, shorter ones. And why is it necessary? We do this because we want to produce more of the shorter hydrocarbons that are in demand, because shorter ones are good fuels. So that's the reason. Right. Another question they could asking you is that cracking is a thermal decomposition reaction. Define thermal decomposition. As I said earlier, the thermal means heat. Decompose means break down. So break down a large molecule into smaller ones by heat is called thermal decomposition reaction. And cracking is just that. And therefore, cracking can be referred to as thermal decomposition reaction. Now, why are long alkanes cracked? Because we want shorter ones, more flammable ones, and they are in high demand. That's the reason. And next one, they say, what evidence is there that the molecule in the products are smaller than those from the starting molecules? Now, because, as we can see here, the starting molecules, they are paraffin oil, they are liquid, and the products are gas form, and therefore you know the molecules has been cracked because they turned from a liquid into a gas. So that's the reason you know. Now, next one, what was the porous port in this experiment? It's a catalyst. It is a catalyst. Okay, and next one, why was the first tube of gas discarded? Because it was air. It was air here. So the first test tube of gas, you do not take it, you just discard, and you start the second one because you want the products, the cracking products, that gas. You don't want the air from here. So the first one you need to discard. Now, next one is Now, what happens when bromine water was added to the tube of gas collected? Of course, because it's carbon-carbon double bond, bromine water will be decolorized. So they are the questions and they are the answers, and I hope that makes sense to you. Now, looking at your work, your school work, you see, looking at the book, you see here is the same thing. And this is the cracking setup, right? Here is the ceramic wool, and it's soaked with paraffin oil, and you have these broken pots and porcelain pieces or aluminium oxide. That is a catalyst. You heat the catalyst, and the paraffin oil is going through this hot catalyst, and it's broken down into smaller molecules, and it will be collected in this tube. How do you know the molecule is smaller than this one? Because here is a gas form, it's a gaseous product, and here is a oil, it's a liquid form. Let's know the products is smaller than the starting material. Now, the two conditions, reaction condition, one is heat, one is a catalyst. You can give a name, it's called broken pot or aluminium oxide. So positive test for unsaturated hydrocarbon is that it turns orange bromine water colorless. That means here this is unsaturated gas, so it will decolorize bromine water, where this one won't. So that's why this one is more useful, more reactive one than the previous one, right? So that's that. And let me see the previous cracking. See here, cracking is also referred to as thermal decomposition because it is broken down by heat. Large molecules broken down into smaller ones by heat. That's called thermal decomposition. And you can see the example here. It's a C10H22. So it can be broken down into three smaller ones. You see C5, C3, C2. So they are smaller ones, but two of those are alkene family. So propene, ethene, they are double bonds. So they can decolorize the bromine water. This can't, but you can see those three products are smaller than the starting material, and therefore they are more useful because they are good fuels. So that is cracking. That is cracking. Now, cracking hydrocarbons. And I hope this is useful. Thank you. Bye.